In this chapter, we're going to review some topics in algebra that will help prepare us for the calculus course that's coming up. And we'll begin by first looking at exponent laws.
Welcome everyone to my series on calculus. What I like to tell my students is that this really is the first real math course that you're gonna do. Up to this point, everything else that you've done has really been just laying the foundation or getting you prepared for the race. But now that we're here, now we're going to start running with it. Okay, and you're really going to see some powerful mathematics come out of this. In fact, there's a quote out there by a gentleman named W.B. Smith. He says that calculus is the most powerful weapon of thought yet devised by the wit of man. And I hope by the end of this series of lessons here that you have an appreciation for what he was trying to get at when he said that. To begin with though, we do have to take a small look back. And in fact, we're going to call this PreCalculus, okay? Which is essentially my way of saying we are going to do a review, okay, a review of algebra. Let's just zoom out a little bit here. Whoops, wrong way, did it again. I'm going to review of algebra here. So what we're going to do to start off with here is I'm going to take a look at some exponent laws. And we're just going to go through some examples of some questions related to exponent laws, and then we'll move on. So the next few lessons here are going to be really just about this pre-calculus, about setting the stage for what's coming up later on in this course. A lot of algebra in calculus, very, very heavy algebra component. In fact, you're going to see in a little while here that when you work through some questions in calculus, the first step might be calculus, but then you're going to be doing all sorts of algebra to help kind of refine and make the answer pretty and easily understood there. So anyway, I'm just going to pick some questions, just some random questions that we typically use in the class here to kind of help review some of these ideas here. So to start off with, what we're going to do here is I want to simplify, okay? We're going to simplify, let's say we'll start off with, what have I got here? Try 4x to the negative, 4x to the negative 2. Okay, and we're going to multiply that by 8x to the negative 2. Okay, now, it should be a pretty straightforward thing. Let's just think about what we're being asked to do here. First of all, order of operations tells us that we're going to have to look inside the parentheses here. Now, because we're multiplying these two together, this is not actually all that necessary that I concern myself with order of operations, because it's not going to really make that much of a difference. However, one of the most common mistakes that gets made at this level of mathematics is to do things in the wrong order. Okay? Sometimes we get so comfortable with the rules, the orders of operations, it's easy to slip into kind of habitual mistakes here. So let's just take a look at this. What does this mean, 4x to the negative 2? Well, that's a rational, remember? 4 over x squared. Again, notice that the negative 2 here is an exponent on the x. There's a power here. The 4 is the coefficient. It's not actually part of that power. The base is x, so the exponent is negative 2. The negative means that we're writing that down here, okay, in the denominator. Same thing over here. The power is the x to the negative 2. The 8 is just the coefficient. Okay, and then when we multiply, I hope this is straightforward. We're just going to multiply straight across here, so we will get 32 over x, and then x squared multiplied by x squared is going to be x to the 4th. Okay, now I could have done that a slightly different way. Okay, I could have come over here and said, okay, well, 4x to the negative 2, 4x to the negative 2. I multiply the coefficients together, that's 32. And then remember, when you multiply two powers that have the same base there, we just simply add the exponents. This becomes negative 2 plus negative 2, which is 32 x to the negative 4, or 32 over x to the 4th. Now, you'll notice that I'm taking it down and writing it in terms of positive exponents. Is that necessary? Is there anything actually wrong with 32 x to the negative 4? Well, the answer is no. No, 32 x to the negative 4, that's fine. Nothing wrong with writing it like that. This is no simpler than this. You're just going to find that sometimes people prefer it if you write it with positive exponents only. So you're just going to have to make sure that you understand what the preference of your teacher is there. Okay, let's take a look at another one, kind of related to that. B. Well, let's try 4x to the negative 2. Instead, let's subtract 8x to the negative 2. Okay? Now, same as before, there's a couple of different ways that you can interpret this. First of all, we might look at the exponents there, okay, and realize that these are they're negative here, and so we might write this in terms of its rational form. 4 over x squared minus 8 over x squared. And what we're going to get here, we've got common denominators already, so it's simply going to be 4 minus 8 over x squared. So the denominator is going to stay the same. 4 minus 8 is going to be negative 4 over x squared. That's one way to do it. Or notice that we've essentially got like terms here. I've got 4x to the negative 2 minus 8x to the negative 2. Well, that's simply going to be negative 4x to the negative 2. And then again, I can write that as in its rational form, negative 4 over x squared. Okay? And hopefully that makes sense there. Now, let's take a look at a variation on that. Let's say, for example, that I had, the question was, what we'll do here in C. Let's say, for example, that it's x to the negative 2 plus x over, let's say, x minus x to the negative 2. Now, this one right here, I just want to make sure that you understand how this works here, that we don't make a really, really predictable mistake here. Oftentimes when people see this x to the negative 2, they want to bring that down. They realize, oh, it's got a negative exponent, I got to drop that across the division there. That's not true. The same thing here, this x to the negative 2, that x does not pop up to the numerator. Not the way you'd immediately think there, and people make the mistake there by doing that. Really what this should be here is 1 over x squared, but that for right now that stays in the numerator. Now, there are other ways that this could be done, but for right now I just want to focus on this way of looking at this problem, just so that you don't get sucked into a very, very simple way of making a mistake here. Yes, I am going to write that as a fraction. No, I'm not going to drop this over the division symbol. And the reason for that is this bar here, and we got to make sure that you're clear on this. That bar, when it's present in an expression here, implies a set of brackets around the numerator and the denominator. Okay? It is implied. Okay? And that means there's an implied order of operations here. I have to do what's inside the parentheses first. Okay? So what that means is I need to do this addition between those two terms first, and because this is the x to the negative 2 implies a rational expression, there's my rational plus my x there. I have to do that before I can do the division. It's an order of operations issue. So now, in my numerator, okay, I look at those two right there. I've got 1 over x squared plus x. Okay, that is going to be the same as 1 over x squared plus x cubed over x squared. Then I do the same thing to the denominator. This becomes x cubed over x squared minus 1 over x squared. And so now I've got 1 plus x cubed over x squared divided by x cubed minus 1 over x squared. Whoops. Right off the screen there. Now I'm doing division. I'm dividing fractions. Okay, I've got fraction divided by fraction. Okay, let's maybe zoom in a little bit here. Okay, so bear in mind, all I've done in this next step here is I've just put together the numerators here, all over x squared. So 1 plus x cubed down here, x cubed minus 1. And so this is going to end up being 1 plus x cubed over x squared multiplied by the reciprocal of that denominator, which will make this x squared over x cubed minus 1. X squared and the x squared, whoops, sorry, that's off the screen again. X squared and x squared, I'm going to cancel. I'm not 100% thrilled with that. I'll explain this in just a second here. So I've got 1 plus x cubed. The x squareds cancel. I've got x cubed minus 1 here. Now, I'm not entirely thrilled with the idea of canceling the x cubes. Here's the problem that I run into. This expression right here and this expression are equivalent. Okay? They're equivalent. They're not exactly the same. This expression is not equal to this one. Okay, so this is a nice thing to talk about right now. They're not exactly the same. The reason for that is this expression right here, that expression on the screen right here, this has got a couple of non-permissibles. X can't be equal to 0. X cannot be equal to 1. Okay, those are two non-permissibles, and they're clearly present in this expression of the problem. Okay, now down here though, what's the non-permissible here? Well, it's just 1. The only non-permissible here is 1. So these are not the same expression. So canceling actually did change this a little bit. In order for me to make this equal, if I want to make these things equal to each other, I simply have to add the restriction here that x cannot be equal to 0. Now they're the same. Okay, now these two expressions are exactly the same. Now you might want to include here that x can also not equal 1. However, this is not exactly necessary. I mean, I can see right here that x can't be equal to 1. What I can't see is that x can't be equal to 0. That absolutely needs to be there, or else they're not the same thing. Okay, just like in the previous questions that we did up here, I didn't really have to say that x can't be equal to 0. It should be clear from the expression that it can't be equal to 0. It's when those things become invisible, that when they disappear, that I need to state them outright. Now, I, being the person that I am, I would actually encourage my students to go one step further here. I would encourage you to make this pretty. There's something about this right now that doesn't look right. Okay? And I suspect if you're watching this, there's probably a few of you out there that know exactly what I'm talking about. That 1 plus x cubed, that doesn't look right. I would change the order of that and make that x cubed plus 1 over x cubed minus 1. And then I have to include that x cannot equal 0. Now I would love to see that as an answer. It's been made pretty. Okay, and when you start making your math look pretty, it will treat you right. It will behave well for you. Okay, it's when you let stuff like this happen where it's not in standard form, where the order of the terms is a little bit off, where you make some of the relationships a little harder to see. And I love the fact that we include that x can't equal to 0. Now, if you include that x can't equal 1, that's good too. Not 100% necessary, but still a good idea. Now, there's a little bit more that can be done in terms of factoring of this, but we'll talk about that in a little while here. I just wanted to get the idea specifically here about how the negative exponents work and make sure that we're working that thing through properly. Let's take a look at a couple more examples here. Okay, make sure I got some room here. Okay, question D. What have I got here? I wanted to take a look at what happens if you've got negative 2, whoops, sorry, negative 2x squared y to the 4th divided by 3y to the negative 5, all to the negative 2. Whoa. Now, again, we're talking about specifically about the exponent laws. But order of operations factors heavily into this as well here. I would prefer that people started inside the exponent, inside the parentheses here. Now that's not necessary. I could actually deal with what's going on here first. But you learned the order of operations. Let's use it and let's stick with it. So let's deal with brackets first. What's inside the brackets? Well, what's inside here is, first of all, negative 2/3. I'm not going to change that. That's about as simple as that's going to get. I've got an x squared, but I don't have anything else, so that's simply going to be x squared. Now I've got a y to the 4th over a y to the negative 5. Now, remember, that's when you've got a power divided by a power and the bases are the same. Okay, then you subtract the exponents. So I've got 4 minus negative 5. 4 minus negative 5 is going to be 9. Okay, and so there you go. So now we have simplified what's inside there. I can't do anything else. Okay, I am multiplying the x squared by the y to the 9th, but I can't move any further than that because I don't know what the values are here. That's about as good as that's going to get. So now I'm going to apply the exponent here, that negative 2. So the first thing I'm going to do here, and this is just a choice on my part here, I'm going to apply the negative. Okay, so that's going to force the reciprocal of this expression. Now, that negative there, the way I've got it written here, you'll think, well, it's going to drop down to the denominator. but the negative can kind of fit wherever it wants. A negative divided by a positive is negative. A positive divided by a negative is negative here. I think I said that right. Anyway, either way, I can leave that negative up there, and this will be 2x squared y squared. And now that square applies to every factor inside here. Now, it distributes through to all of these things because there's no addition or subtraction here. Bear in mind, this is not subtraction, that's a negative sign. There's nothing in front here to make this a subtraction. This is just a negative sign here. So that square is going to distribute to all of the factors there. So negative 3 squared is going to become 9. 2 squared is 4. X squared squared will be x to the 4th. Y, whoops, wow, I forgot, I didn't pull down the 9 there. Wow. Sorry. This is a lot easier when there's students in the room to scream at me when I get things wrong here. Y, the 9 there is going to become y to the 18. Okay? So hopefully that makes sense there what we did, just the order of operations. If you're really strict with the order of operations, you should be fine here. Let's take a look at one last question here. Let's say, for example, sorry, what letter was that? A, B, C, D, this is E. Okay, here's another one. Let's say we've got 3 to the 3x multiplied by 9 to the 3x minus 2, 81 to the x all over, 27 to the x plus 2, root 3. Okay, there's a fair bit going on here, and I want you to simplify this, just like we've been doing with all of these things here. Now, this is a skill that you should have practiced back in one of your previous courses here, but again, we're pulling out these old skills because they're important. The first thing I would do here is notice that in all of these factors here in this expression, the bases of all of these powers are essentially powers themselves of 3. So this is like this is 3 to the 3x. There's nothing really I can do there to change that. But that 9, that's going to become 3 squared to the 3x minus 2. Over here, 81 is 3 to the 4, all to the x there. Divided by 27 is 3 cubed to the x plus 2. And the square root of 3 is simply going to be 3 to the 1/2. Now, do I need to put the parentheses there? Well, look, the more comfortable you are with this, the more you can do, the more quickly you can move through this. Okay, but if you're not about to, in this very same step here, multiply these things through, then no, you need to put those parentheses there, or else you're going to get it wrong. Okay, let me show you the mistake that gets made if you're not doing this correctly here. So 3 to the 3x, bear in mind what I got to do here is order of operations. I have to deal with the exponents first. Okay, and so I have to deal with this power of a power. So this is 3 squared to the 3x minus 2. This is going to become 3 to, well, to the what? Well, when you have a power of a power, you have to multiply the exponents. But the 2 is not just multiplied by the 3x here. The 2 is multiplied by the 3x minus 2. That gets you 6x minus 4. That 2 has to distribute to both of those terms in that binomial exponent. Please make sure you do that. If you don't put the parentheses there, you're creating the opportunity to forget that. Now over here in this last one, this is not usually so hard to forget here, just 3 to the 4x, that's kind of straightforward. Down here though, we run into a similar problem. The exponent on that 3 there has to distribute to both terms of that binomial exponent there. So it becomes 3 to the 3x plus 6. And then multiplied by 3 to the 1/2. We'll deal with that in just a second here. Now, I got a bunch of stuff going on here. But I'm kind of lazy, essentially lazy here. I'm going to do this all in one step here. Notice that I've got a whole bunch of powers multiplied and divided together. All of the bases are 3, so my base here is going to be 3. Now, when I multiply powers together, I add exponents. This is going to become 3 to the 3x plus 6x minus 4 plus 4x. Now, I am dividing this, although, by these two powers. So I'm dividing by this power first. Remember, I'm going to do this in order, left to right. So I'm going to divide by this power, which means subtracting that whole exponent. So subtracting 3x plus 6. Then I'm going to divide by the 3 to the 1/2. So subtract 1/2. And now we just put this all together. This is going to be 3x plus 6x is 9x plus 4x is going to be 13x minus 3x. Sorry, did I say 14 there? Let me do this again here. 3x plus 6x is 9x plus 4x is 13x minus 3x is going to be 10x. Then I've got negative 4 minus 6. Okay, well, negative 4 minus 6 is going to be negative 10 minus 1/2. Now, you might be tempted to put negative 10.5 there, which is fine. It might be easier to say negative 21 divided by 2, though. That kind of looks better. Those fractions always kind of strike me as looking better than the decimals there. Anyway, we just wanted to do a little bit of practice with simplifying exponent laws and fractions like that. Okay, hopefully that gives you a little bit of help here. Now we're going to take a look at a slightly different topic.
Now we'll review the process required to simplify rational expressions.
All right, so now obviously we're going to be talking about simplifying rationals. This is something we did just a few minutes ago with some of those, with one of those questions in particular with exponent laws, but we're going to do a little bit more with this. Now, some of you are going to be very, very familiar with this. Others of you this is going to be something that has caused you problems in the past. And so this is why we're going to take some time taking a look at this. We'll do a handful of examples here, probably 6 or 7 different examples. I'm going to be trying to grab different concepts here to illustrate as we go through this. So to start off with, let's just take a really quick look at a basic one here. Let's say 4 over x minus 2 plus, say, 3 over x plus 6. Okay, what is this going to be equivalent to? Okay, so in order to add fractions together, add these rational expressions together, what we need is a common denominator. Okay, so you have to understand this. This is like 4x minus 2ths plus 3x plus 6ths. So if you want to think of it like this is like adding 4 of an unknown plus 3 of an unknown, if you want to think of it like that. I can't really add those together until those unknown portions are the same. Now, the easiest way to do this is to simply create these what we call common denominators, okay? And you're all familiar with that. What we're going to do is we're going to create equivalent fractions here where we're going to change the denominator here. Now, where the problem comes up and why I grabbed this particular question here, because it's not a hard question, but it's an easy one to also mess up here. X is not common. Please don't think that X is common here. X is in both of those denominators, but it's not what you call common. Okay? When we say common, usually the word that is not stated but is implied is common factor. And X is not a factor of either one of these expressions. Okay, it's an addend. Okay, I'm subtracting 2 from it here, I'm adding 6 to it here. I'm not multiplying by anything there. So X is not a common factor. In fact, really what I got to do is I got to think about putting parentheses around those and adding those together. Oh, sorry, and finding a common denominator based on those. This is the factor in the denominator. This is the factor in the denominator. Some of you are going to assume, well, can't I just cancel the 2 out of there, cancel the 3 out of there? No, you can't, because order of operations, again, implies that there's a set of brackets around the numerator denominator. Before I could do that division, I would have to simplify what's inside there. I would have to subtract the 2 from the x here, and until I know what x is, I can't do it. That's a dead end. So for us, the simplest thing to do is to simply create the common denominator, and we do that most clearly here by simply multiplying those together. So here, I'm going to multiply the numerator and denominator here by x plus 6. This will be 4x plus 6. Okay, over x minus 2, x plus 6. Okay, I'm going to add to that. Over here, to get that same common denominator, I have to multiply by x minus 2. But that involves multiplying the numerator by x minus 2, multiplying the denominator by x minus 2. Now, once I've done that, Notice that the denominators are basically the same. Now the order is backwards, but that's okay. Order doesn't matter with multiplication, so maybe I'll leave that as x minus 2, x plus 6. Up here in the numerator, I'm going to distribute the 4 through, so it'll become 4x plus 24. I will distribute the positive 3 through. Now I set it as positive 3. I'm adding it, but I'm going to just treat that as positive 3 there, so plus 3x minus 6. And now I'm going to simplify the numerator. So 4x plus 3x is 7x. 24 minus 6 is going to be positive 18. I am going to leave the denominator in factored form because if I don't, I may accidentally run into a scenario here where I'm forced to look for factors to cancel out. And if I expand this out, then I'm going to have to factor it again. So I'm going to leave it like that. That is my final answer. Ideally, what I would try to do is simplify by canceling out a 7 or factoring out a 7 and then canceling like factors, but I can't do that here. That's as simple as it's going to get. Okay, let's take a look at another one here. B, my letter B here. What if it was negative 4x over 2x plus 3 cubed plus 1 over 2x plus 3 squared? Okay, now there is a purpose to this question here. Okay, I want you to understand why I'm doing this here. Notice that the denominators are basically have the same factor in them. So they are the same. The difference is the number of times it shows up as a factor. Now, the common denominator here, or the shared multiple here, has got to be 2x plus 3, to which exponent here? Well, it's got to be cubed. It's got to be cubed. Notice that here, 2x plus 3, in order to get have this cubed, there has to already be 2 of them in there. This has to be 2x plus 3 times 2x plus 3 times 2x plus 3. There was 2 of them there, and then there was an additional one. Here, this only has the 2 factors of 2x plus 3. This does not have enough to qualify as the common denominator. So I have to multiply the numerator and denominator on this fraction right here by 2x plus 3. So this will be negative 4x over 2x plus 3 cubed. Don't have to do anything there. But this then has to become 2x plus 3 over 2x plus 3 cubed. Now the denominator is the same in both expressions. And then I would simply, well, in this particular case right here, this particular case here, because it's addition, and there's no coefficient here, I don't really even need those parentheses. This becomes negative 4x plus 2x will be negative 2x plus 3. Oh, now, can I cancel those things out? Because I see a 2x there, 2x, 3, and 3? No, I can't. The reason why I can't, okay, is because there's addition here between those two terms. This is not a factor that I can simply cancel with this thing down here. These 3 is not a factor in either the numerator or the denominator. Neither is the 2 or the 2x there. They're not factors. Okay, they're add-ins. They're being added or subtracted, if you will, from another expression there. So I can't even cancel out the 2x plus 3 with the 2x plus 3 down there because this is negative 2x plus 3. Okay, the expression is not actually exactly the same there. So that's as good as that's going to get. Okay, let's keep going. Let's grab another one here. What would be another good one? Okay, let's try this one. Let's say I had 5 over, let's say x squared minus 3x minus 18. Let's add to that 2 over x squared plus x minus 6, let's say. Okay. Here's a good one, a good kind of general question about this. This is something you should have done any number of times, really. In order for me to figure out what the denominator is, what the lowest common multiple of those denominators, I really need to break these things apart into their factors. Okay, I don't want to end up multiplying this by this and expanding everything out here, especially if I don't have to. Now I will if I can't think of another way around this. But for right now, there might be a better denominator than multiplying those two together, but the only way to see it is by taking each of these trinomials and factoring them. So here, what are your factors of negative 18? Okay, that differ by that 3 there. And that is going to be negative 6, positive 3. Okay? Multiply those together, you get negative 18. Add them, you get negative 3. Good. Over here, this will be adding 2 over, okay, well, this is going to be x and x to get the x squared. I'm looking for factors of negative 6 that add to be positive 1. Now, because it's negative, they're going to be opposite signs, and because it's addition here, the larger one is positive, so this is going to be positive 3 minus 2. And now you should see why this was so beneficial to me. X plus 3 is a common factor. Now, not the x, not the 3, x plus 3 is the common factor. Now, I'm going to kind of move this along a little bit here. So my common denominator here, the common multiple here is going to be x plus 3. And then what are my leftover factors here? Well, x minus 6 was over here. Okay, actually, you know what? I would be smarter to write it like this. Sorry. For those of you that maybe struggle with fractions, it might be easier to see it like this. I'm going to write that x plus 3 in the middle here. Maybe this will help clarify why we do it like this. X minus 6, x plus 3. Then I'm going to multiply by x minus 2. Now, watch what happens here. If I cover up this last factor here, I'm retrieving the first denominator. If I cover up the x minus 6, I'm retrieving that second denominator there. I need to be able to do that, to have the correct denominator there. Now, what factor did I introduce over here to the denominator? I introduced an x minus 2, so I have to have another x minus 2 up in the numerator. Over here, I introduced that x minus 6, so I have to introduce an x minus 6 in the numerator. Now what I'm going to do is I'm just going to distribute out in the numerator 5 times x, 5 times negative 2, 2 times x, 2 times negative 6. I am not going to expand out the denominator. I'm going to leave that. Whoops, and you can't see that anymore. I'm going to leave that in factored form, just in case I can cancel a little bit later on. 5x plus 2x, 7x. Negative 10 minus 12, negative 22. Over x minus 6, x plus 3, x minus 2. Okay, well, I can't factor that out, which means I'm not going to be able to simplify that any further. I'm going to leave it like that. I like it. I'm done. Okay, now let's try another one. This one's going to be slightly different. It's going to have a slightly different approach to it, or at least there's going to be something else that we can do here. So 3x minus 3 over x squared minus 5x plus 4. And we're going to subtract from that this expression here, 4 over 16 minus x squared. Okay, now before we even start this, before I jump into this at all, when you take a look at this, something should jump out at you as not being very pretty. And it should be this bit right here. Look at that. That's not in the right order. 16 minus x squared, I don't like that. I don't like that at all. I would prefer that the x squared came first here. So what we're going to do here, and I'm going to do sort of 2 steps here in one. Okay. What I would do here is I would change the order. Now watch what I do here. Because there's a negative in there, I got to be careful. I'm going to move the x squared in front here, but because it's subtracting x squared, I need to maintain that. It still has to be subtract x squared plus 16. Now I like that order a bit better. Now, I don't like the fact that the x squared is negative though. So what I'm going to do is I'm going to factor out the negative. I'm going to do this all kind of in this step right here. Just erase that and do it again. I'm going to factor out that x squared, the negative. That's going to change the sign of both terms in that expression. The x squared was locked into a binomial. When I take a negative out of the one term, I got to take it out of the other term. Okay, but now I'm subtracting a 4 over a negative here. Now that means, really, you know how this works. You've been doing this for a long time. That subtracting a negative is going to turn that into a positive here. That's where that gets to. That is a much better way to write that question. I'm much happier with it looking like this than I am with it looking like it did in the original question here. Okay, now I'm going to add those 2 fractions together, but the denominators are different, so I need to do some factoring here so that I can tell what's going on here. For the time being, I'm also, well, I tell you what, let's factor the denominator first. Let's do this first. So this is going to be x I've got a positive 4 here, a negative 5, which means these have both got to be negative, and it's got to be negative 4, negative 1. Now, look at the numerator here. 3x minus 3. There's a common 3 there. I'm going to factor that numerator right now. Now, I wouldn't always do this, but I can see right now, even before I write it down, that when I take out a 3, I'm going to be left with an x minus 1. I like what I'm seeing there. I really like what I'm seeing here because I'm going to be able to simplify that a bit. Plus 4 over. The denominator here is a difference of squares, so it'll be x minus 4, x plus 4. Wow, that's happening a lot to me, breaking. And notice that I've got a common factor of x minus 4 there. I like that as well. So, what we're going to do to start off with here, I am going to cancel that out. So this will become 3 over x minus 4 plus 4 over x minus 4, x plus 4. Oh, but, I can't exactly say that. They're not equal. That's actually a little bit of a lie. They're not equal. They're equivalent. They're close. They're not equal. The reason for that here is because this expression here has a non-permissible value at x equal to 1. X can't be 1. It leads to an undefined value for this expression here. However, this particular version of it doesn't. This has no issue at 1. 1 is fine. Plug 1 in, you'll see there's no problem here. They're not the same. If I want to keep working with this, I need to state that x cannot equal 1 in order for these two to be equal here. Here, it naturally couldn't have 1 as a value. Here, I have to state it. I have to include that as part of my answer here. So this has now got to stick with me all the way through. Okay, now my common denominator is going to have that x minus 4 in it. And right there, I have I've got that initial denominator, but I need another factor, x plus 4 here, to finish that off. Now this one is missing that x plus 4, so I have to put that in the numerator as well. Plus 4. Oh, don't forget to write this. Okay. Oh, now someone's going to ask, oh, do I have to? Would you mark it wrong if I don't? Yes. That's important. They're not the same otherwise. Multiply the 3 through, so we get 3x plus 12 plus 4 over x minus 4, x plus 4, assuming x cannot equal 1. Now I'm just at the very end here. So 3x plus, well, that's going to be, 3x plus 12 plus 4 is going to be 16 over, I'm running off the edge of the paper here, but that's okay, where x cannot equal 1. So 3x plus 16 over x minus 4, x plus 4, where x cannot equal 1. Now, awesome. Love that answer. You might want to include in here that x cannot equal positive or negative 4 as well. It's not necessary because I can see it. I can see that there's a problem there. That x can't equal 1 though. That I can't see from this solution, and I need to include that. Okay, let's keep going. Okay, now we want to take a second here to work on some complex fractions. So let's take a quick look here. So let's say we've got 2/3 minus 1 over 6y, 1 over 5y, plus 2 over 3. So we're just going to take a couple seconds here and work through some problems that are a little bit more complicated. Now, bear in mind that that division symbol right there implies a set of brackets around the numerator and the denominator, meaning I have to do what's inside there first. So look up here first. Notice that my factors here, I've got a 3 here, I've got a 6 and a y there. My common denominator, okay, well, I'm not going to just multiply those together and say 18y. Well, that's not necessary here because 6 is a multiple of 3. So if I simply make that 6y, I'm good. But what did I need to multiply by 3 to get to 6y? Well, I had to multiply by 2y. And if you do that to the numerator here, you will get 4y. That denominator, that 6y, is the common multiple there. So I didn't have to do anything to that expression, so I'd leave that as 4y minus 1. Now, there's my numerator. Let me put that in parentheses. Down here I've got a 5y here and a positive 3. Now, 5 and 3 are both prime numbers. Okay, there's not going to be any smaller common multiple than just the product of the two of them. So in other words, it's just going to be 15y as my common denominator. That means here I had to multiply that by 3. Here I had to multiply this by 5y. So this will become, because the 2 up front there, this will become 10y. Okay, that's looking fairly gross. I'm not particularly thrilled with that. Okay, in a second here, I will show you I'll do a problem here where I'll do this in a slightly different way, and it'll give you a sense of another way to approach this. But anyway, so now what I'm going to do is because I'm dividing a fraction by a fraction, I'm going to multiply now by the reciprocal. So 4y minus 1 over 6y. And we'll multiply by the reciprocal of that denominator. So 15y over 3 plus 10y. All right, now when I multiply those together, the y's will cancel. A factor of 3 will cancel between the 6 and the 15, so that'll leave me with a 2 here and a 5 there. And now there's really nothing common there between those guys, so I'm going to be left with 5 multiplied by 4y minus 1 over 2. You know, and I don't like the way that's written right there. I don't like the 3 plus 10y. It doesn't look very pretty to me. I'm going to change the order. It's adding anyway, so changing the order doesn't really do anything. And there we go. So 5 multiplied by 4y minus 1 over 2 multiplied by 10y plus 3. Now, I can't just state that because I did something up here to change this expression a bit. I divided those y's. Now, y divided by y is 1 everywhere except where y is equal to 0. So I can't allow y to equal 0. So there's that non-permissible that exists here that I got rid of. So I need to state it if I'm going to be able to confidently write that these are equal to each other. Okay, so that was necessary. Had to do that. Good. Let's keep going here. It's fun. EF. Okay. What was the next one I wanted to do here? Okay. 1 over x plus h minus 1 over x all over h. Okay, so another complex fraction here. This is a really important pattern. Okay, I want you to just remember this one. This is one of those things you're going to kind of lock onto, and we're going to dredge this one up a little while later in this course. So first of all, we're going to leave that h in the denominator. Now here, x plus h and x. Remember that when we talk about what's common, I'm not talking about the fact that there's an x here and an x there. I need to be common factors. And x is not a factor of x plus h. So what I've got here is I've got this x plus h, this binomial factor down here, and then this monomial factor right here. The only way I'm going to get a common denominator out of those is to multiply them together. So what's going to happen here is my denominator here is going to be x plus h multiplied by x. That's the best I can do. That means here, in this denominator, I was missing the factor of x. So if it's missing in the denominator, it's missing in the numerator. Got to put it there again. Wow. Minus, now here's where there's going to be likely some problems for people. I had to multiply the denominator here by x plus h, which means I got to multiply the numerator by x plus h. Now, do I need to put parentheses around that? Yes, I do, because I'm subtracting x plus h. A lot of times if people don't put the parentheses there, they simply write this as x minus x plus h. And then they wonder, well, why am I getting things wrong? Well, because here, what are you subtracting? Just the x. Not the x plus h, just the x. As soon as you put parentheses around it, now you're subtracting the x plus h. So yeah, you do need parentheses there. When I distribute the that negative through, you get x minus h all over. And I'm going to change the order of the factors in the denominator because I like it when it looks more like that. X minus x. Okay, those are going to cancel. I'm going to be left with negative h over x times x plus h all over h. Oh, wow, I moved quite a ways off the screen there. Sorry about that. Now I've got negative h over x times x plus h divided by h. Now, this is a fraction divided by a whole here. Or not a whole, I don't exactly know what it is, but it's not written as a rational here, but I can think of it as a rational and change this into negative h over x multiplied by x plus h, and now multiply this by 1 over h, the reciprocal of that. The h's cancel, and I'm left with negative, that subtraction doesn't disappear, negative 1 over x multiplied by x plus h. And that's true as long as I add one little stipulation here, h is not equal to 0. H cannot be equal to 0. That's a non-permissible that exists here that doesn't exist here. So I need to include that expression before those can be considered equal. Okay, let's take a look at another one here, EFG. Okay, we're just going to do we'll do a couple more here. 1 plus 1 over x plus 1 over 1 plus 3 over x minus 1. Now I want to show you something that you can do here that'll kind of make your lives a little bit easier. It is very difficult for us typically to work with complex fractions, fractions within fractions here. It is often easier, I'm going to just do this off to the side, it's often easier to rewrite the expression like this. Make this 1 plus 1 over x plus 1. And I'm going to put the whole thing in parentheses here. Because remember, that's what that bar implies. And I'm going to write it like this. Divided by, and in parentheses, 1 plus 3 over x minus 1. I have done nothing. I have done nothing to this problem. I have just taken a vertical division statement and turned it into a horizontal division statement. Turns out though, when you're dealing with complex fractions, this is a little bit easier to think through. Now I have to deal with what's inside the parentheses individually first. So now this is going to be equal to, well, it's easy to come up with the common denominator when there is only one denominator. So this has to become x plus 1 over x plus 1 plus 1 over x plus 1 divided by, and the same thing here, x minus 1 over x minus 1 plus 3 over x minus 1. Now, this will become x plus 1 is going to be x plus 2 over x plus 1 divided by, I still haven't gotten outside the parentheses, okay, I'm still working inside. This will be x minus 1 plus 3, so x plus 2 over x minus 1. Okay, so now I've simplified the individual parentheses there as far as I can go. Now I'm going to apply that division there, and I'm dividing by a fraction, so I'm going to multiply, actually, you know what, and now that we're here, I'm going to do it like this. This will be x plus 2 divided by x plus 1, and now we're going to multiply by the reciprocal. Oh, but I really like what I'm seeing here because I'm seeing a common x plus 2 in the numerator, x plus 2 in the denominator. Those will cancel. I'm going to be left with simply x minus 1 in the numerator over x plus 1 in the denominator. And that's true so long as I state the non-permissible that I just got rid of, which was x cannot equal negative 2, because I divided that out. These are not the same until I state that. Okay? That's a good one there. All right, let's quickly do one more. Okay, h, I've got 1 over 2 plus h squared minus 1 over 4 all over h. Now you should recognize that pattern slightly. We did something similar to that above. Now, it might be easier for me to write this out like this. Okay, 1 over 2 plus h squared minus 1 over 4 divided by h. You might find it easier to even write something like this horizontally. It doesn't matter. But if it helps, it helps. My common denominator here is really got to end up being just the product of those two denominators. So it's going to end up being 4 multiplied by 2 plus h squared. So the factor that I'm missing here in that first fraction was 4. The factor that I'm missing here was the 2 plus h squared, and then divided by h. Now, my denominator, 4 multiplied by 2 plus h squared. My numerator here, I have to do the subtraction here, but the only way I can do that is by expanding that out. So this is going to be 4 minus, now I'm subtracting everything here, so I'm going to get a 2 squared is going to be 4. So 4 minus 4, 2h plus 2h is 4h minus 4h, h squared minus h squared, all divided by h. And when I simplify that, 4 minus 4, it's going to end up being negative 4h minus h squared all over 4 multiplied by 2 plus h squared divided by h. Now, actually, at this point right here, I'm going to, because I'm running out of room here, I'm going to change this real quick. This is like multiplying, dividing by h is like multiplying by 1 over h. And notice in this case here that I can factor an h out of this. Okay, I can factor an h out. In fact, I'll take out an h here. So it'll be h multiplied by negative 4 minus h over 4 times 2 plus h squared multiplied by 1 over h. And then that h will cancel with that one. And so I will be left with, up here, this is going to be equal to negative 4 minus h over 4 times 2 plus h squared, once again, finally with the stipulation that h cannot equal 0 in order to maintain that those are equal. Okay, so we've done a lot of that. Hopefully that gives you a good sense of how to deal with exponents and how to deal with fractions. I know this was long, a lot of practice here, but these tend to be skills that are important in this course, and I want you to be prepared for it. So anyway, when we come back to this, we're going to start to look at some polynomial division and some rationalizing.